Integration by substitution. Made easy. Example number 1. We want to find the integral of radical 2x minus 1 dx. Looking at our problem, we don't have a formula that we can use to solve this. That's where the substitution of variables comes into play. What we're going to do is let this inner function equal to u. And since that's a u, this dx term, we need to change that into a du. So our variables here can match. The way we do that is we're going to say, I want to let u equal to 2x minus 1. Now, let's take the derivative of this. If I take the derivative, I'll have du with respect to dx is equal to the derivative of 2x minus 1 with respect to x is just 2. From here, I want to solve for dx because I want to change that. So the way I do that is by just moving the dx over and then moving the 2 to the other side. What we'll have is dx is now equal to du over 2. Now what we can do is rewrite our integral. So we have the integral of radical u, since our inside function is now u. Then we'll have dx, which is now du over 2. From here, we can go ahead and simplify. So I'll have 1/2, just bringing out the constant, times the integral of u to the 1/2, which is just the radical written as an exponent, du. All of that work that we just did was to get this in a form that we know how to evaluate. So let's go ahead and evaluate this. I'm going to bring it up top here. We're going to have 1/2 times the integral of u to the 1/2 is going to become u to the 3/2, since you just add 1 to the exponent, and then you put the denominator as 3/2 since it's the exponent as well, like that. And then since this is an indefinite integral, we have to include our constant, plus c. From here, let's go ahead and simplify. We'll have 1/2 times 2/3 u to the 3 over 2 plus c. Now let's distribute the 1/2 to everything inside. What we'll get is 1/3 u to the 3/2. 1/2 times a constant is still going to give us a constant. So we have this so far. Now we only have one step left. Remember how we changed our inner function to become a u? Well, now we have to change our u back to what the original value of u is supposed to be. What that means is that we're going to have 1/3 times u, which we know is 2x minus 1. So we'll put 2x minus 1 to the 3/2 plus c. This is going to be our final answer. Example number 2. We're given a definite integral this time. Whenever you have a composite function, usually what you want to do is let the inside function here be our u value. And then this dx, we want to turn that into a du, so the variables match. So we know that u is equal to x squared plus 1. To find dx, what we do is we take the derivative of this. What we're going to have is du over dx is equal to the derivative of u is going to be 2x. Now we can solve for dx. dx is equal to du over 2x. Let's go ahead and box these right here because we're going to be using these. All right, so Since this is a definite integral, we have to look at our limits here, which is 0 and 1. These limits are with respect to x. However, we're changing everything with respect to u. So that means we have to change our limits as well. Let's look at the lower limit, 0. The way we get our new limit is we plug 0 into every x that is equal to u. So like we said, u is equal to x squared plus 1. So for our lower limit, which is 0, we're going to plug that into every x here. So we got u is equal to 0 squared plus 1, which is equal to 1. This is our new lower limit. Now let's look at the upper limit. We do the same process. U is equal to, and now we plug that number into every x, squared plus 1 is equal to 2. That's going to become our new upper limit. Now that we have our u, our dx, our upper and lower limits, let's go ahead and rewrite this integral. What we're going to have is the integral sign, and then now our lower limit is 1, and our upper limit is 2. This x is going to stay the same, and we have x squared plus 1, which is equal to u cubed, and dx is equal to du over 2x. What we can do from here is simplify. As you can see, we have an x here, which is going to cancel with this x on the bottom. And we can bring our constant out to the front, which is 1/2. So rewriting this, we'll have 1/2 integral with limits 1 to 2 u cubed du. Now this is in a form we know how to solve. Let's go ahead and take the integral of this. What we're going to get is 1/2 times the integral of u cubed is u to the 4th over 4, and our limits are 1 to 2. And you notice that we don't put a constant of integration. That's because we have a definite integral here. So let's go ahead and solve this. What we'll have is 1/2 times, we first replace our u's with the upper limit, which in this case is 2. So it's going to be 2 to the 4th over 4, subtracted by our lower limit is going to go into the u's this time now, which is going to be 1 to the 4th over 4. Let's go ahead and solve this. So we're going to have 1/2. 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 over 4 minus 1 over 4, like that. And now we go ahead and simplify further. We have 1/2 times 16 minus 1 is 15 over 4. Now the last step is distribute the 1/2. So from here, we're going to have 15 over 8. And that's going to be our final answer.